Welcome to episode 5 of Working with Exponents. And today we're specifically going to be working with exponents where you're given negative exponents in the question. If you'd like to go back to episode 4, where I gave a handy hack for working with negative exponents so that you actually alleviate having to work with the negative exponent itself, I am going to bring that into this lesson as well. But specifically here, we're looking at where you're given a negative exponent in the question, like for instance over there. So we can't directly use that hack. We need to go through some of the other steps as well. All right, let's have a look at this very carefully, especially at the numerator. We need to notice that the 9 is standing outside of the bracket that's being raised to the power of negative 2. So that 9 is not affected by the power of negative 2 at all. So we're going to write that down exactly as it was. The contents of the bracket is being raised to that power. So remember, if we have a power raised to a power, we're going to keep the base and we're going to multiply the exponents. So 3 times negative 2 is negative 6. And then in our denominator, we don't have any brackets, it's just simply 3m squared. And remember, you're always going to keep writing it down in the next step, even if nothing's been done to it at the time, because we're going to be using it at a later stage. So if we look at our coefficients, we've got a 9 and we've got a 3, so that's very simple to say 3 goes into 3 once and 3 goes into 9 3 times. And then here we're going to be using the rule, and I've put the rule up there so that you can refer to it all the time. So if you remember that n to the minus 1 actually means n to the minus 1 over 1, so that is acting as being in the numerator. Maybe it will also make it a little bit clearer to you. And then also remember that when it's becoming 1 over n, it's becoming 1 over n to the power of 1. So we can see that as something moves from the numerator into the denominator, the negative exponent is staying the same numerical value, but its sign is changing. The same would happen if I had an n to the negative 1 in the denominator. I could take it to the numerator as n to the power of positive 1. So that's basically what we're applying all the time. So let's do this the easiest way, the most logical way. That 3, that coefficient 3 is going to stay in the numerator. And then this negative 6 is going to come down to here. So I'm actually going to do it sort of a long way to show you the actual thought process that we're going through. The m squared is already in the denominator. This m to the power of negative 6 is going to come down and become m to the power of positive 6. And remember, when two variables are standing right next to each other, it means multiplication, which we can show as a dot or a bracket or a times sign. And with my 3 in the numerator, over here, if I'm multiplying two powers together, then I have to add the exponents. So I'm going to get m to the power of 8. And that is my final answer, because I've given any exponential values with a positive exponent. You may not leave your answer with a negative exponent. All right, let's have a look at 4x squared, bracket, 4x all to the minus 2. So this can be very confusing, because people get confused as to what that exponent refers to and what that exponent refers to, as in what is it affecting. So if we look at this bracket doesn't have an exponent outside, so it's not being raised to any other power. So actually this bracket is there just to confuse you. This 4x squared, nothing's being done to it at the moment. So I'm going to write it down again just as 4x squared. I'm putting it in my suitcase to keep it for later. This 4x is all in a bracket which is being raised to the minus 2, which means that everything here inside the bracket is being affected by that exponent. So it's going to be very difficult to think of raising 4 to the power of -2. So in this case, I would say, let's change that negative exponent into a positive exponent by applying this rule first of all. And because it's affecting this whole bracket, it means that that whole bracket is going to go into the denominator, and the exponent that's affecting the bracket is going to become a positive exponent. Here, remember, if there is no denominator, it's like having it over an imaginary 1. So if there is no denominator, then think of all this as being in the numerator, and then you take it down to the denominator. So let's go through the step where we first of all get rid of the bracket in the denominator. So all of this is raised to the power of 2, which means 4 squared, which is 4 times 4, which is 16, and x to the 1 being raised to the power of 2. I have to write down the base, and I have to multiply the two exponents, which gives me 2. So when we see x squared, we could think of it like this. If two powers are being divided by each other, then remember that the rule is keep the base and subtract the exponents. So that would actually give us x to the power of 0. And we remember that x to the power of 0 means 1. The easier way to do this is if you have two things that are identical, the same base, the same exponent, you can just know that they're going to cancel out, because when we multiply anything by 1, it just remains the same. And now I've got a 4 in the numerator and a 16 in the denominator. A lot of people will write down an answer of 4, which is incorrect, because if you look what's happening, 4 goes into itself once, 4 divides into 16, 4 times, so the answer is not 4, the answer is 1/4. And here we've ended up with no variables in our answer, even though we started with variables in the question. Let's have a look at something with a little bit more detail. 25, x to the 5, y to the -3, z to the 3 over 30, x squared, y cubed, z to the power of 6. Right, we need to work with the coefficients. We've got variables of x, y, and z, so we're going to need to work with each of them in turn as well. So what I'm going to do here is I'm going to use a little bit of my hack from episode 4, and I'm also going to use a similar thing to over there where I deal with that negative exponent. But let's first of all work with the coefficients. So coefficients are numbers. We need to treat them as we always have. What will divide into 25 and into 30? What times table do they both belong to? Very obviously the 5 times table. 5 goes into 25 5 times, and 5 goes into 30 6 times. All right, so now we've got x to the 5 divided by x squared. When we're dividing, we need to subtract the exponents. And here I'm going to use the hack where I say to you, is it top or bottom heavy? So there's an x to the 5, x squared, it's top heavy. So that x is going to remain up at the top. And the difference between 5 and 2 is 3. But let me not forget to write down my 5 that's left over there as well. I already know I've got a denominator because there's a 6 there, so I'm going to set it up. Now here I have the problem of dealing with a negative exponent. So I'm going to do what I did over here, and I'm going to take the whole power down to the denominator and change the exponent into a positive. But I can do this in my head instead of doing that whole extra step. This is going to come down to the denominator as y to the power of +3, but I've already got y to the power of +3, so y cubed times y cubed, I must add the two exponents, and I'll get y to the power of 6. Then looking at my z's, there are no negative exponents, so I can use the hack. is it top or bottom heavy? There's my bigger exponent at the bottom, so I know that my z is going to end up at the bottom. And what's the difference between 3 and 6? The difference is 3. So there's my final answer. And as you've noticed, I've worked with the coefficients, then I've worked with the x's, then the y's, then the z's. Some of them needed slightly different techniques to the others, depending on what situation I was given in the first place. But if you go progressively from left to right, step by step, you can't really go wrong. Right, let's bring in a negative number now. We haven't had one yet. A negative coefficient, that is. Y cubed z to the power of negative 3 all over 14 x to the power of 14 y to the power of 3 z to the power of 2. Okay, so like I said here, work through the coefficients, then each of the variables in turn. Now, because we haven't just got positive coefficients, we've also got a negative. We've also got to go through the step of working out the sign. And that is so simply, according to the rule of signs, negative divided by positive is negative. So the overall answer is negative. Looking at the coefficients, 7 goes into 7 once, 7 goes into 14 twice. So straight away I can see that I'm going to have a denominator. I'm going to put my 2 in the denominator straight away. I don't need to write down the 1 unless all these things disappear, which we can see they're not going to do. So now, x to the power of 6, x to the power of 14, neither of them are negative exponents. So I need to decide, is it top or bottom heavy? It's bottom heavy, so I know that my x is going to end up at the bottom. What's the difference between 14 and 6? It's 8. Y to the power of 3 divided by y to the power of 3. Very similar situation to what we had over here, so we can just actually think of them as cancelling out. I'm going to eat my words. We are going to need our 1 at the top, because if you look very carefully, this z to the minus 3 is going to actually need to move into the denominator. It's going to become z to the power of positive 3, and then I've got z squared times z cubed, which means I need to add the two coefficients, and it's going to give me z to the power of 5. And the reason I need to have that 1 at the top is because those cancelled out, the x's ended up in the denominator, so did the z's, and so I need to show that what's left at the top is simply a 1, and that will be my final answer.